All right, so we are on page 70, and we're going to treat the work today kind of as your part of your warm up that's there. So on your syllabus, you've got 2 lines of work that's listed. So no video. We're done with the videos for this particular unit that we're working in. So last night in your notes, we saw that sometimes the X's go away or the letters go away. And when that happens, that changes what our possible answers are. So you've always been used to just getting one answer. Well, now we have to interpret our answer. And that always comes around when the letters go away. So let's look at problem number 1. We're going to use our rules. I got to get all the letters to one side, all the numbers to the other. Well, since the number's already alone, this minus 211, I'm going to subtract an X from both sides. And by doing that, I get negative 211 equals, and then X minus X. Well, that's 0. So again, letters went away. I don't have any letters. So when that happens, we've got to ask ourselves if we have a true statement or if we have a false statement. And that's what we're going to keep on coming back to. If it's true, all right, then that means it's what's called infinite solutions, which means no matter what you put in, it's always going to be a true statement. If you have a false statement, then it's what we call no solutions. So it doesn't matter what you put in, it's never going to work. And that's the idea in question number 1. Like whatever you plug in for X, when you take away 211 from it, it's not going to equal what you started with. So in this particular case, we say no solutions. All right. Let's go on over to problem number 2 that we're looking at. Now, starts off as normal. All right. The 3's up against parentheses, a little distributed property. So the idea here is that we're not going to know right away. I know the direction says without solving completely. I'm going to have you solve completely. All right. I think that's the better thing to be doing right now. Eventually, we want to get you to where you're not solving completely. And then we have an equal sign, and then I've got 3m minus 9. So get all the letters to one side, get all the numbers to the other side. So if I subtract my 3m, I'm going to get it to the left side. Again, the m's are gone. So I'm left with negative 9 equals negative 9. Well, is that a true statement? Is negative 9? Yes, it is. So in this particular case, we say it's infinite solutions. And then infinite, like as to infinity as and beyond, Buzz Lightyear, we're just going to keep on going. But yeah, we have infinite solutions. No matter what you put in, it's going to result in true. Let's go to problem number 3. All right. Again, what side you want to start with doesn't make a difference. Check it to the left, to the right. I'm going to add the X over because that is adding, which is nicer than subtracting. So when I do that, I'm like, oh, wow, negative X plus X. Well, that's gone. So I just have 5 equals 5. Oh, that's a true statement. So, yep, we are at infinite solutions that we're looking at here. So, recognizing that the letters can go away, and when they do, you've got 2 options. That true statement or false statement, infinite solutions if it's true, no solutions if it's false there. So, look at problem number 4. All right, I'm going to add the 4m over. And the reason why I chose to do that is it makes them positive. If I go the other side, I'm playing with negatives. All right, so I've got an 8m. I got a plus 12. And on the other side over here, I got my 12. All right, I'm going to subtract my 12 away. Now, here's the thing. Don't just assume that because I got a 0 that we're dealing with no solutions or infinite solutions. It's only when the letters go away. The letters haven't gone away here. I can solve this equation. I can divide both sides by 8, and I can get 0 equals m. So in this particular case, there is one solution. And that's what you're seeing. And so the directions were like, hey, determine the number of solutions. All right. So when we solve these, we can get one solution, which you've been getting like your entire math career. But now we're going to run into situations where we have lots of answers and then we have no solutions. Once we start graphing on your calculator, we'll start to get the visual to go along with it. Yeah, that's what we're dealing with here. Let's go ahead and let's try problem number 5. So I've got a negative 3x. I got to distribute. So it's a minus 6 and then negative 3x plus 6. So in this particular case, again, get all the letters to one side. I'm going to add my 3x over. Now the x's have gone away. So it's negative 6 equals 6. Well, wait a second. Letters have gone away. So I can't get an answer as in one solution. Does negative 6 really equal 6? No. So, yep, that's going to be no solution. That's there. All right, let's do one more here. I'm going to clear my fractions. So again, normal solving equation skills, which means I'm going to multiply every one by 5. Because if the denominator is 5, well, that means that least common multiple is 5 as well. So when I multiply, and I like to make it always 5 over 1, so I can see the 5 is upstairs, I can see the 5 is downstairs. Well, 5 divided by 5, that's a 1, so it's just an x minus a 3 equals. All right, again, 5 divided by 5, 1, just an x. 5 divided by 5, so it's just that minus 3 that's there. Now, remember they did say without solving completely. One of the things that we do want you to start to recognize is, do you see how it's the exact same thing over here and the exact same thing over there? When they're the exact same, yeah, it's going to end up with it being infinite solutions because they're the same thing. So anytime they are the same, then we're going back to the idea that that is a true statement. So we're going to say infinite solutions. That's there. So let's dip down a little bit here. Down here, all right, same ideas. But what we want to keep in mind is we might get an answer. And if we do, we want the answer. So let's go to problem number 8. That's there. All right, so distributive property. 3 times a is 3a. 3 times 6 is my 18. It's a negative 2. So negative 2 times a is negative 2a. Negative 2 times a, negative 6. That's a positive 12. And that equals 6. Now, again, I could get no solution here. All right. We're going to combine like terms because that's always before we start moving things left and right. Let's combine like terms. So you can see there's my equal sign. So let's combine my 12 with my 18. All right. That's 30. Let's combine my negative 2a with my 3a. Okay. That's just an a. So I got a plus 30 equals 6. Well, all right. Subtract the 30 over. A equals negative 24. And so, yeah, I got an answer. That's fine. So, again, only when the letters go away does something end up happening that's there. All right. What we want to watch for is down here. All right. We want to fill in the blanks of the following equations so we meet the criteria. So we're on the next page. All right. It says in there may be more than one answer. Okay. So in problem 17 is we got to fill in there an equation that yields one solution. Okay. So if it's one solution, the x's cannot go away. So as long as they're different, all right. So if I make this just a 2x, I'm going to end up with x's at the end. I don't care what the other number is because the big thing here is when you have different amount of x's, you're always going to get one solution. Now, no solution. All right, we need the x's to go away. So if I have an 8x over here, I need an 8x over here. And then, because I want no solution, I want it to be a false statement. So I don't want the numbers to be the same. So I can make it like 100. That'll mean it's no solution. Now, for these guys here, if you're like, I'm not really following you here, like this is, whoa, like that's why we're talking through it there. And as you start to see more, you're going to start to recognize it sooner, which goes back to why at the beginning of the video, I was like, hey, let's like actually solve it right now. We do want you to start to see them. An equation that yields infinite linear solution, which means we need the same thing on both sides. All right. So I have an 8x plus 24 here. So they want to know what can you put in here so you also get 8x plus 24. Well, I'm going to put an 8 here, which means I have to multiply them both by 8. So that'll just be a 1x, because 8 times 1x is 8x, and 8 times 3 gives me my 24. Same thing on both sides. That makes a true statement that's there. All right. So here's what we want for you guys. You can go ahead, say goodbye. All right. You are finishing up, all right, your page that's here. You have answers that are up on the board. So you can get yourself up there to check as you go. Maybe you do a few and you check. Maybe you finish a page and check. And then do realize that we also have page 78 for you. So I'm just going to kind of 76, 77, 78. And yeah, we're kind of in. So 78, page 78 is kind of a review assignment that's there. All right. There are 9 problems. We will be checking in on this tomorrow. We also see our Socrative quiz tomorrow on A, B, and C. So I would encourage you to look at those particular warm-ups that you have and make sure that those are organized. So again, you are finishing that page 70 and 71. Check the answers up front. Then you're going to page 78. And then again, we have the answers up front so that you can check those as well. Let's see if I got everything for you guys today. All right. Open video, play it. 70, 71, 78, quiz tomorrow. There you go, people. All right, we're done.